Okay, so this lecture is meant to go over with you the concept of combining vectors, adding vectors. And I'm going to show quickly how to do it graphically and then looking at how to do it mathematically. So remember that vectors have both a magnitude, so they have like a size, and they also have a direction. So they point this way, they point this way, they point this way. So when we're adding vectors graphically, we have what's called a head-to-tail method, meaning that the vectors are lined up head to tail. And so, for example, if I have two vectors, one is 3 meters, and then I have another vector that is 4 meters, and then I've got a teeny one that is 1 meter. I would line them up graphically. I'd say, okay, here's my 3 meter, here's my 4 meter, and then I've got to line it up. The head of this one's the tail of this one, so it's going to go backwards just a bit. There's my 1 meter, and my resultant is always from the tail of the first vector to the head of the last vector. So another way to think about that is it goes from the starting point to the ending point. So start to finish. So graphically, that would just be from here to right there, which would just be 6 meters. And again, if it's along the same direction, it's pretty easy. They just add and subtract. When they are in different directions, when they could say they're going, one's going vertical, one's going horizontal. So another example is if I have, here's my 3, and I have a 4. I'm going to do the same way. I'm going to do head to tail. So here's my 3. Here's my 4. And it's going to go from my start to my finish. So here's my start. Here's my finish. And that's my resultant. How far away is it from the starting point? So in this case, this is 3, 4, 5. It's a perfectly 90-degree triangle. And so graphically, we just know this. This would be 5. So let's kind of talk about the mathematics of this. So when adding vectors mathematically, if vectors are perpendicular to each other, we just combine all the horizontal vectors, and we then combine all the vertical vectors, and then we Pythag them. So combine all the horizontal vectors into one. One horizontal vector. And sometimes you only have one, and so there's nothing really to combine. And then we would combine all the vertical vectors into one vertical vector. And then the last thing you would do is you just use the Pythagorean theorem to combine the horizontal and the vertical. You would use Pythagorean theorem to combine Pythagorean to, this shouldn't say combine. It should say, you'd use the Pythagorean theorem to find the resultant. So that's just how you would find the magnitude of your resultant. But to find the direction, it's a little trickier. I'm going to take these boards down because I need more space. To find the direction, we're going to have to use property from geometry, the SOHCAHTOA. So for any right triangle, if I were to think about this, if this is like my starting point, and if I were to call this angle theta, that angle theta, with respect to this triangle, has an adjacent side and an opposite side. And this is our hypotenuse. Okay? Now we know good old Pythagorean theorem. Pythagorean theorem says, and let's kind of do the classic A, B, C. Pythagorean theorem just says that A squared plus B squared equals C squared. So if you know two sides of a right triangle, you can always find the third. But you can also figure out the angles, okay? So there's a relationship called SOHCAHTOA, right? So hopefully this is not the first time you've seen SOHCAHTOA, but SOHCAHTOA is just a way to relate the sides of a right triangle to the angles in a right triangle. And this relationship says that the sine of this angle is equal to the opposite side divided by the hypotenuse, that the cosine of that angle is equal to the adjacent side divided by the hypotenuse, and that the tangent of that angle is equal to the opposite side divided by the adjacent side. So those are just your basic trig functions. We're going to also utilize the inverse trig functions, and that is the concept that if I were to take, I could say that my angle could be equal to the inverse sine of opposite divided by hypotenuse. Or that my angle could be equal to the inverse cosine of my adjacent over my hypotenuse. Or, there's more, that my angle could be equal to the inverse tangent of my opposite over my adjacent. Okay? So let's just look at a really basic example. This says a hummingbird flies 9 meters east and then flies north for 3 meters. What is the bird's resultant displacement? So if I were just to graphically draw this out, here is where my bird starts, and he goes 9 meters east. So that is 9 meters, and then he goes 3 meters north. So my resultant is going to be from where I start, right here, to where I finish. That's my giant question mark. So in terms of magnitude, magnitude is easy. Magnitude is just doing Pythagorean theorem, right? I'm going to say, well, 9 squared plus 3 squared is equal to my resultant squared. And so my resultant, and if I were you, I would pause the video, I would get out my calculator, I would crunch these numbers, but I'm not you, and you might be lazy, and you might just say, tell me what it is. So hopefully you're doing the right thing, and you're pausing it, and you're actually practicing on your calculator. But when you do that, you should get a value of 9.49 meters. Okay? So that's pretty easy to do that on a calculator. Now, in terms of the direction, what is that angle? So if I'm looking at my triangle here, I technically know all 3 sides, but it's usually best to work with like your original values. So if I were to look at my original values, I know this side, and this side is my adjacent, and I know this side, that's my opposite. So I know my adjacent side and my opposite side. So if I'm kind of looking here at which of these I could utilize to find my angle, the one that has adjacent and opposite is my tangent function. So if I were to say, okay, well, theta is going to equal the inverse tangent of my opposite over my adjacent. So it's going to be my opposite side, 3, divided by my adjacent side, 9. So in your calculator, you go 3 divided by 9 equal, and then you would apply the inverse tangent button, and you should get, if you're in degree mode, that's key, huge, big, you got to be in degree mode. We don't have wild radian nights in this class, we're only in degree. If you're in degree mode and you apply that function, you should get an answer of 18.43 degrees north of east. And we'll talk about kind of what the difference of north of east versus east of north is when we get back to class.